code walkthrough, but before that, I just wanted to talk about this library. I think we all know about this library, right? We use this in our Spark testing, right? And it's from Holden Karau. If you go to the wiki page, okay, and if you go to these data frame generators, okay, you will see that you have an ability to provide a schema like this, okay, and you have an ability to then provide ask the context to generate some arbitrary data frame for you. Okay, so this was the inspiration, or this was the basis of our library. If you see here, same thing. You provide a column name and then you say generate one of these names and choose one of these numbers. Okay, and then what you can do is you can ask this data frame generator. On that, you can call arbitrary data frame with custom fields, things like that, and then it would help you generate all these data frames. Okay, so this is how the data frames will be generated for you. Okay, so keeping this base, but there were two problems that we were mainly trying to address when we were going ahead with data frame utility. One definitely was ease of using the library. If you see this also, although this is good, but this involves a lot of boilerplate. Okay, and that is where we wanted to ensure that we are doing away with the boilerplate. It's easy to write the test cases even. Okay, and finally, another very important item was, can we go ahead and reuse the same pieces that was available and build something workable on top of it. Okay, so if you have gone through our page, you already know the constructs. Okay, so these were the main items, that whether we can write something and which was easily extensible. You can also write some other extensions. So right now we don't support array, we don't support map type, we don't support any case class type. So you can also start looking at the code and contribute to building all these things. Okay, and then another thing was, I had seen it was becoming very cumbersome to write all these geotype specific attributes every time during the test. We would write the ad ID and gender and age and all those things again and again. We would put them. Okay, and finally, our tests were mostly where the data was being provided by us, and we wanted to move to a place where we would write property based tests. Okay, so these were the basic constructs. So without further ado, I'll just jump to the code. One second. Hmm. From a code perspective, I just want to, I think you already know the constructs, so no point in recapitulating the same thing. So the base of our uh, framework, if I have to talk about, one second, the base of our framework is this class. Okay, this is again a type class. This type class is called data generator. Okay, so if you really see the difference between these two frameworks, okay, what this framework is saying is, I just like to compare both of them so that you get a fair idea of what we are talking about. So what do you need here? You need a column name and you need some of the values to choose from. Okay, and in the data frame, they will give it to you in any order possible. Okay, so we needed a way to control how much of the values will be generated. Okay, now it might be the case that you want a skewed data set. Okay, so you would want, say, this Holden to appear like 90% of the times in the column, and rest of the two times you just want this name to appear. Okay, so those kind of options also we needed. Apart from that, we wanted to keep it straightforward, simple enough. So what we wrote is this data generator, and if you see here, what you need is a generator of something, generator of something. Okay, so if you see how this type class has been written, is it is a data generator of A, where the out, like we said in type class, you should be using the A type somewhere. Here we are using it in two places. One is generator of A. So this would, if you're trying to generate string data, this would return you a generator of string. If you're trying to generate int data, it would return you a generator of int. And then we have a list of these values which are also of type A. The list of values means these values. Sometimes it will be string and sometimes it will be int, right? So we wanted them also to be passed. Any list of A can be passed. And then there is something, if you can see here, there's something called data option. Okay, let's go to data option now. So if you see here data option, so if a naive implementation is always present. So you just, then you just have to wire up your data set and start testing with it. You can just say, okay, hey, there's this data set. Just give me some data set. I want to write my test cases using it. So you use always present. Okay. But there can be a scenario where you want your data set to be always uniform. Okay. So what that means is if you have four values, say for this, if you can see here, okay, uh, if you can see here, if you have these values, okay, you have zero point 0.7, zero point 0.1, 0.8, 0.4, what you would want is more or less uniform. So we did some tests and we figured that it cannot be exactly uniform because it also depends on other columns that you have. What if some other columns, the total number of rows are not even uniform, right? So we cannot give you exact uniform distribution, but more or less this will be uniform, okay? And if you see here, uh, these are one of the examples that normal always present will produce to something like this, but always uniform will produce to something closer. And always skewed roughly means that one or two values will be always skewed in your data set. Okay, and you could maybe you're looking to write some tests or something like that based on that. So these were the two data options we have found for now. We are also exploring other data options, so you guys can think of it and contribute it here. But as of now, we didn't find any use case, but we are welcome to contributions from your end. Okay, so one second, let me go back. So this is my data generator class, which which we work with. Okay, and let's see how it is being used now. Okay, so again, utility, everything is under this utility Spark package. Okay, and this guy is under this traits. Okay, and another trait I would like to show you is this trait. Okay, this trait is your data type trait where we have our own data types. Why? Because we didn't want to couple this, with the Spark data types. We had our own data types. Once you provide us the data types, we'll do the internal, configuration. But maybe we can change it to the Spark data type. Now that it is coupled to Spark, it makes sense even. Okay, but that time we didn't do it. Okay, we can change this probably. Okay, and there is one more important thing that we want to talk about. These are the base I'm building to show you the framework. So, say suppose this guy, we have something of a representation of a data column. Okay, whenever for people who have used it, you already know there is a representation called data column, and in that data column you have a name of the data column. So think of this as one column. What can it consist of? Any column in Spark, okay, what can it consist of? It will consist of a name, it will consist of a data type, it will consist of a data option, which is again your some which I've already shown, right? The skewed, right? The column, the data will be skewed or uniform or things like that. And then a list of values, which consists the values in these columns, okay? Which is male, female, whatever. There's a list of values. And then we have another class called Spark data frame, which takes a vararg of data column. Okay, where we'll use this, we'll come to that. We just need to pass these set of data columns, and then everything will be taken care of thereof. Okay. Next, look at this. So we have kept this. So now we could have given access to data column directly. Okay, but then that violates one very important principle, which is like then we can our data column tomorrow, if I have to extend something where data column I'm not able to fit it within data column, I would have to change my data type. And anybody who is using data column directly, their contract would be broken, right? If I change this data column, and if you were using the data column directly, in the next version, your code would break because data column is no more available, in the next version. Maybe we can do some versioning of stuff, but we still wanted to keep it fluid as such. Okay, so what we did was we gave access to these classes. Say suppose I want to come up with an array column, and it is array column is not fitting in this way. Okay, here. So what I can do is I can add something like an array column tomorrow. Okay, here I can add something like an array column tomorrow. Give still the same data column method as my front user facing interface, and internally what would be created is an array column, and user don't need to know about my data type that I'm trying to use here. Okay, so that's the idea. So that's why you always interface, you always call data column, and then only you are able to access data column using that. Okay, so this is how you create a data column. Now where is this data column being used? Okay, so if you see there are in this thing there are two distinct stuff that you have to do. Okay, one distinct thing, or one distinct, while creating the generator, one distinct thing is creating the schema, and another distinct thing is creating the generator. So there is a schema part of it, and then there is a generator part of it, which is this guy. Okay, so we had to somehow fix that, so that I take just enough information. So the focus is on just taking enough information from the user, and then custom writing your APIs, so that all of these internal, nitty gritty details are taken care of. Okay. And the basis of that is these two things, data column and Spark data frame. Okay. So now let's move on. So if I go to ops now, let's see. So this is the data column ops. Okay. Let me go here. Let's look at this. Okay. So we have two methods here. Okay, guys, 1 second. Just 1 second. Okay, guys, sorry for the disturbance. So let's go back here. Yeah. So these are the two distinct parts of it. Okay, now let's look at these two methods. Okay, these two methods hold the crux of it, if you look at it. So what we are saying is, now if you think about it, if you give me a data type, okay, I'm able to generate a schema for you. Okay, the data type is this data type. Okay, this data type. If you give me string or something, we all know that the structure remains same, right? Struct field, from this data column I get the name. Okay, and I can set the string type, and I can get the schema for you. Okay, and then finally, if you see here, uh, I have this data generator. What it does is, it this is the type class usage that we are doing here. If you have a type class for string, we can call the get on it. Okay, and pass the options and values there. Remember, get took an option and a values ka list. Okay, so in this get, we can from, and data column already has these options and values, just in a different name. Okay, so what we did is, from data column we pass the options and the values here, and what we got is a generator of your scene. The output type here is a generator of your data, this thing, of your string or whatever it is. Okay, so it's not inferring anyways. So here also same. So I'm saying, now look at this thing. So one good thing to notice here is, it's not just anything. We can, using this generator, we can generate even a Java lang boolean, right? It's not just the Scala boolean that will be respected here, because it's a generic interface. Whatever you put here will become the implementation. So I would like to show you now this class. If you see, this class has something to do with the idea how you can call a data generator of string. Okay, this is the type class uses that I'm trying to show. How you can call a data generator string and do a get on top of it is, if you have something in scope which has the definition with it, and that is, the scope is this guy, data generation ops. Okay, so if you look at this data generation ops, okay, we have different generators pre-configured. Okay, pre-configured for long boolean double integer string. What it did was, this is a custom implementation of data generator of Java lang boolean, and we are saying implement the get. How we have implemented the get is, there is a helper somewhere, and there, if you see in that helper, okay, in this, whatever data you've got in this helper, we are checking. Look at this helper. Helper takes a data and a values, right? Data is the data option, and values is the list of values, and it checks what kind of data option it is, and accordingly it generates the value, right? Think about it. What is it? It's basically, we want to generate one of these values, right? So here it checks the data option, take just one of koi bhi ek generate kar do. If it's uniform, then we are saying, oh, hey, there is a frequency involved. Uniform is basically based on frequency, right? Okay, something will be more frequent, something will be less frequent. So we have a helper method for that. Okay, and that helper methods does some shuffling and does some. This is all part of the generator interface. This one off, and then providing a frequency to the one off. Okay, so you can read about that. This is all part of generator. Okay, but the idea is I'm just trying to show the design of the interface. Okay, so to keep things decoupled from one another. So what we did was, now that we have created this generators, boolean, long, double. Okay, you have, for each of them you have a separate generator. Okay, which is again generating based on the data option which you have provided. Whatever data option you provide, the values will be used. The generator will be configured to generate those kind of values. So we generate the values based on the generator. Generator is configured to be either skewed or uniform, and that is based on what data option you have provided. Okay, so this is the um, crux of it. And I think this one has a get skewed frequency. You can just go through the implementation, but the idea is that. Okay, so here we have this generator, okay, which generates the values for you. So if you see, we have solved two parts of the puzzle now. We have got the schema somewhere. If you see, this part of the puzzle is solving the schema part of the problem. कि कैसे मैं नाम पास करके उसका डेटा यहाँ पे तो डायरेक्टली पास करना पड़ रहा है. How can I do it just by providing one data column, one unified interface? Okay, so this is the schema part which is solving, and this is the generator part. There is a generator also, which with the same name you have to generate data also. So this part is solving the generator part of it. Okay, now we will see how they are being used. Okay, let's see how they are being used. They're being used here. Okay, so it was very easy for us to directly provide a get schema also to you. Okay, so look at this. We have something called get schema. What it does is, what we were proposing is, provided you provide us with this schema. So how do you call this is, look at this guy. So the design here is, there is an implicit class again, SparkOps, which takes a data frame. Okay, what is a data frame? Data frame is your vararg of data column. Okay, keeping this in mind, which is this, you will do it yourself. It's a DIY Spark data frame. Okay, you might use add ID, you might use age, you might use data column of your own choice. Okay, you build this Spark data frame using that. Okay, and what this guy does is, this guy takes a Spark data frame as an implicit parameter, this implicit classes parameter, and then it provides different methods on top of it. Right, this was covered in our type classes thing. Okay, so on this Spark data frame, we have provided something called get arbitrary generator. Okay, what it does is, it just same thing, same code. If I just have to show you, it's the same code. Data frame generator dot arbitrary data frame with custom fields. See, data frame generator with arbitrary data frame dot custom fields. Okay, and there I have to pass a Spark session, which I have said is implicit. Wherever you're writing a test case, the requirement is you'll have to make your Spark session implicit there. Okay, so here I think we have written that in our contract also. Yeah, here you have to make the Spark session implicit. Okay, so we're taking an implicit Spark session using the same context, same Spark session context which you have passed. We are wiring it here, and now you have already given the information in your Spark data frame, right? How your data columns will look like. Using that information, okay, we start. If you see here, using that particular information, we start going over the data frame. Okay, we map them one by one to column, because this is the structure that is required, right? Each data frame should be part of a column. Whatever structure you have given should be a column, right? So what we do is, we take that, we take your data column, we map them to a name, and this generator gives me, okay, why this generator is callable here. Look at this. We have made this again an implicit class. Okay, so it looks like as if the data generator is available on data column. So we can directly call based whatever data column you have passed. You've hardwired this data column for us, right? These data columns have been hardwired for us by you. Whatever hardwiring you have done on that data column itself, I can directly call the generator, because it is an implicit class. Okay, so we were able to directly call the generator, and the generator will resolve everything. You want a string, and you want from this list of values, and you also want a skewed data set. So it will figure out all of that from data frame, data column. Okay, and it will create a new column. All it needs, this column, if you see, um, this guy here, all it needs is a generator and a name, right? And that's what we are providing here, name and the generator. That's it. And then finally, you have to call an arbitrary on top of it. Okay, this gives you a generator of something. Same to same goes for schema. Whatever you can directly call this get schema just by instantiating this data frame. You can do a get schema on top of it like this, get schema, and it will return you an actual Spark schema. Okay, so this is also done by the same manner. We get the data frame generators, we get the data column that is present within it, we do a map, and on each of them we just do a generate schema, and finally wrap them in a struct type. That's it, right? That's what it is, right? It's a struct type that you need, and all the struct fields should be wrapped inside it. So the struct type being constant, we just generate the internal material here, and what you get is a full-fledged schema. And if you see, for just to get one data frame, we are using our own method, this arbitrary method. What we do is, इसी method को call करके, calling the same method, we just say sample. There is on arbitrary, you get this thing called sample. Okay, it just gives you one data frame, which is an option of a data frame. Okay, so all we are doing is we're using this method and calling a sample, and there you are. You get the entire one data frame based on whatever definition you have provided. That's it. Okay, it is as simple as that. Just some few pieces here and there, and we are set up. Okay, so this is one very important part of it. This data generator part, how we have kind of designed the interface so that it sounds also very intuitive. Okay, and the next thing that I would like to show is, now if you see here, we have said that you can already directly call add id and age and all these things. Okay, internally they are also data column. How that design works is something I'll want to show, because you can reuse this design again and again in every project that you're working with. Okay, so let's see. Okay, we have provided helper methods. See, for add id, let me show. For add id, we have provided one helper method. What is this helper method? See, internally there is some constant that we have written. There is a constants file. Okay, internally this constants file has a add id ka definition with it. What is that add id? It's a data column again. Okay, it's a data column where the name, when you're asking for add id, we are saying you don't have the way to redefine the name. We are saying it's add id. We're naming it for you. It will be a string. So so one of the targets, if you remember, was to get out of the box support for most common geotap attributes. So we know that you want to use this, right? So what you've done is, you're saying this is string. This will be the default type, is it will be always present, and we are generating some random UUIDs for you, because right now data mein hum 1A 1B ऐसे करके देते हैं. We wanted to generate some random UUIDs for you, and this is getting generated from our random UUID method, which is actually a UUID. We are taking some random UUIDs and filling a list and giving back to you. And if you see, it's all the same interface. This also gets, finally, ultimately, what you get out of it is a list of 20. This is the size of the list. Okay, if you look here, this is the size of the list. Based on whatever count you are providing, we are just filling that list for you. But at the end of the day, it will still conform to the data column ka interface, which needs a list of A. Okay, so this is how all these things are hardwired for you: add id, age, gender, app usage, blah blah. Okay, and then when we go back, we've just provided helper methods on top of it. So directly, we are giving this add id back to you, whose type is a data column. Now let's say you want to change the data option on that. You don't want always present, you want always queued. So we have provided another helper method, okay, where you can pass your own data option. On that, you just have to call add id and pass your data option. The functional way of doing it is to copy, not to change, not to create a new case class, but to take the old case class and copy on top of it and set whatever options you have provided to the existing options, right? This one already had an existing option always present, right? All we are doing is, you can think of it like we are copying that and we are setting it with the new option. That's it. If you want to override the values as well, same thing, copy, change the option and change the values. And this is all that we need. Okay, tomorrow we can extend it by changing the name also. But then, agar sab kuch hi change kar diya, then you can as well write a new data column, right? If we gave like everything change kar sakte hain, copy, data type bhi change kar diya, data option bhi change kar, then it would not. What makes it add id, if you think about it, is the name and at least the data type, right? If not the data option and the how you want to generate it, right? अगर ये दोनों भी change करना है, then you can as well make a data column. So that's why we thought that giving name as an option, add id पे name change कर दो या data type change कर दो, didn't really make sense. Okay, because that is what makes it an id. Otherwise, it's just another data column. Okay, and that's what we adhered to. We're just giving these two options for you to change. Okay, so that was one. Uh, this technique was very helpful in us while we were writing other parts of the code as well. How I'll show you. Now, say suppose we figured out one use case that sometimes add ID generally, or let's say not add ID, sometimes say suppose age. Age generally is an integer. Okay, let's see what we provide here. We provide age as an integer, but somehow your use case is you can write your age. You want your age as a string. Now then you will have to cast it or do something, and we don't want that. We wanted one easy way of doing it. So what we figured is our helper methods again to the rescue. Okay, so see, right. So what if you remember, it is very easy. So look at this. Let's look at age first. Okay, age returns a data column. Okay, and data column is the implicit type for this class. If I go ahead and on data column, if I'm able to call as string. So first you wrote something which would be like, say, I don't know whether it will be add ID. Okay, let's see. I think it will be writable here. You wrote add ID. What this add ID will give you is this guy. Add ID and not add ID. My bad. My bad. I should write age here. Okay. Okay. What this age guy will give you is this age, which is integer and some random ages, right? Now you might want this as a string. All you have to do is as string. Okay, and second, yes, I'm able to import it, and this will give you a string representation of it. Why I was able to do it is because everybody returns a data column, and data column, all the methods are kind of built on this data column itself. So मैंने उसमें as string में क्या किया कि DC पे बस कॉपी कर दिया, डेटा टाइप अगेन चेंज कर दिया. पहले डेटा टाइप था int, अब डेटा टाइप उसका कर दिया string, and it is able to generate a string for me. And this is the pattern we have used everywhere for int. Okay, now it depends on the user. If something is a string, you want to convert it to a boolean and it's not convertible, then there will be error. Same thing we did for null. So now say suppose in your age you want proper valid ages and you want a mix of null also. Some values should be null because that is how you want to test it. So we gave a very simple interface for that. All you have to do is as string dot with null. That's it. You're set. You're done. Okay. Okay, there's some issue here. Okay, as string does not. So how we have defined it is as string does not require a this thing. Yeah, null also does not. So it's more of a fluent syntax that we have. Yeah, you don't even need to give a bracket. You don't even need to close a bracket. Okay. So it's like as if you're writing a fluent syntax. Okay, so you say age, give to me as string and with null. So null will also be present now in your data set. And what we did is again same thing, just copy in your list of values which was already present. Okay, add a null to that, and then null comes in the mix of the generator, and generator will automatically generate nulls for you along with other values which you have. Okay, same goes for with junk. Okay, what we did was because it's available on a data column, we took the data type. Okay, and we matched. Hey, this is string integer, and we said we have predefined things here. कि boolean के लिए कोई junk बोल के कुछ है नहीं, like that we are saying, and because you cannot fit in anything in a boolean column, right? But for string, what we are saying is we have put these are the junk value: string null, empty string, and a literal saying junk value. And then for integer, we have max value and min value. For long, also same max value, min value, and we are saying this is our junk values. When all you have to do is you will have to go back here, okay, and just say dot with junk, and your data will have null and will have junk and will be a string. Although if you see the initial data type was hardwired to be a integer and with a particular thing, but on the way we changed it, And this would be the definition of your you know column. Basically, you're basically defining your columns, and here we have provided what does junk value mean. Okay, so I think this is a very good interface to have this implicit class, and how we can use this implicit class to change things on the way, on the fly, basically. And that is what the all these are leveraging, if you see. Okay, so this is one part of it, I think. Okay, anything I'm missing? Okay, so yeah, I think this is one part of it. And apart from that, we have provided also some random generators, which is basically, we knew that, now if you're saying out of the box, you just can't provide the columns if you don't provide the values. So we have provided some bundle IDs. Okay, just some random bundle IDs out of the box, some raw IABs out of the box, some uh, categories out of the box. And mind it, these are proper values. None of the places you will find some ABCD values. No, in app category you will find proper app category values: game, social. Maybe we'll add to this. Right now there is only 4 of them. In simple date format, or rather in date, we'll actually find actual dates which support this format. Okay, tomorrow we can look at extending. The idea was easy extensibility. So tomorrow if you need something, I would probably want you to come here and add something here. Okay, so that your custom need is filled. So instead of writing it in, hard coding it in your test cases, you have to come back here, add it, and then use it in your test cases. Once you add it, this, so how you can call this guy is, so if I have to say here, we can say data column. Okay, this guy here, and we can say some column name. Okay, and data type is say d string, and we have inside data option, we have always present. Now look at this guy. This is how you have to use this. You have to use a random data generator. This guy, random data generator dot. You have so many options here. So I think this is important to first show how to use it. Okay, you have date, UUID, country, OTR, raw IAB, age, all these things, and your data will be generated custom bootstrap from here. Okay, you can always pass your own list of values here, but what we are providing is a set of values pre-configured for you. So if you see something which is happening again and again, your data, that kind of data you're seeing across projects, you want it. Okay, it would be better to add it here and then use it in your project rather than hard coding it as a list of values. Okay, so that's what we are trying to do here. If you just directly say country and you say I want 5 different values of country, so what this guy is going to do is this guy is going to go and pick 5 different values. Now you might say I want 20 different values, then this would not work because we don't have an exhaustive list, but you get the point. You can always come back and add here. Okay, so the idea was to provide easy way of using it. The ease of use was of most important here. Okay, so this is what we were trying to provide. Okay, you can put age and things like that. Okay, just go through the API, you'll figure out. So you don't have to even custom build the values. Even maybe you want a country with or a date column with your own timestamp name. Okay, you can just pre-configure all those things, and once you have configured, simple, build the data frame and start calling the methods. Okay, and the idea for this code walkthrough is so that you can start uh, you know adding to this library. That's the most important point here. If you don't add to this library, then what will happen is eventually we'll again fall back to using our own types, which we don't want. Okay, so yeah, I think that's about it. Any questions, guys?
Joy, one question. I'm just
Yes,
wondering, the Studio UI that we use today for setting up ingestions, right?
yes,
Um, could we piggyback on that? Like, for example, what I'm just what comes to my mind is, let's say I'm gonna generate some test data, right, for a certain
yes,
specification. Now in the Studio UI, anyways, I've got that ability to set up the specification, right? And then it gives me the option to like set up what kind of transformations I want, right? So if
yes.
I could, like, I don't know the actual UI, but I'm just wondering if we could generate the same kind of configuration,
Mhm.
or maybe consume the same kind of configuration, or maybe like create a wrapper on top of this to consume that configuration to actually generate, would it make sense?
We can do it in a test case. This has been written to write, wire your test cases ekdam in your local machine, the unit test cases that you write. This has been wired to do that. I'm not sure if we can, call the Studio DB while, because I would have to. So what you're saying is the data resides in the DB, fetch them and use them to randomly generate the stuff, right?
No, what
So
I'm saying is, imagine that. So one is like I'm trying to think how I'll use the data that is generated. Right. One is, as you said, when I'm writing my unit test cases, I can generate the data using this library and
yes,
use that for my test cases. Right. That is one. What I'm
yes,
wondering is, what if I want to like generate data for a. See, I know that typically for a data partner ingestion, we get some kind of a sample data, right? Or maybe not sample data. Once everything is set up, we might even test it in production, like on some production data set itself, right?
yes.
What I'm wondering is, see, your studio ingestion configuration already specifies what the data schema is gonna be like and what level of transformation and all is required on top of it, right?
Yes.
What if, like, could we potentially generate, like, use that as an input to actually create some test data as well?
Yes,
And
we
that
can do that.
becomes
I mean,
my.
we can write something which will generate the test data. That is absolutely possible. Okay, this library is more towards making the basically. I really did not like how we were writing everything hand built. If you look at this data frame suit base, okay, we write all these things, hand build these things, int double, and then we put all these values and write the tests. Okay, and that it takes a lot of the part of the page of IntelliJ, but after that, the test case is just 2 lines probably, and
Right.
to wire up the test case is like most of the, like, out of 70 lines, maybe 60 lines is just wiring up things, and then 10 lines of code. So just to reduce that initiative overall, and then hardwiring का problem ये है कि people then move away from property based tests. While if you don't give people control over the data, then they have to write property based tests because they don't know what will come in the data, and that's what is more likely to happen in the real world also. Real world, you don't know. Client is promising, but you don't know that data will come in your data set or not, right? They're saying, okay, I'll send gender in this column, but they send age, and we will have to guard against that. So it's better that we randomly kind of generate something, and it's more towards that, a more usable, I would say, this same library, but more usable and more property based, definitely. That's how I look at this thing.
Yeah. I mean, see, from a library standpoint, this is perfect. All I'm saying is, like, maybe just a wrapper on top of it to, like, to
Yes, yes,
do
yes,
something very
definitely.
specific, right? Like,
Definitely, we can definitely use that in because we have all the data in our DPMC DB.
right,
We are not
right.
using it. That's our fault actually. But we have all the data available. We can use it to randomize and generate data sets. Absolutely possible. Absolutely. Cool. I think if there are no other questions, we'll wrap it up. I'll stop the recording.
Yeah.